Hello, this is Jesse Miles. This is my chapter 17 homework. I'll just jump right into it. For the first one, we had an initial omega-1 and an angular velocity there of 10 radians a second, and we knew that would omega-2 would be 90% of that. And then we solved for T1, U1 to 2, which equals T2. So then you add them all together. Go ahead and solve for I, and then you also solve for your theta, which is your m times theta is your u1 to 2. Next, we had this one here with A and B. B is free to move about, A is fixed, and then they are L apart. And then you do some substitution, some solving again for T1, T2, U1 to 2, equate them, substitute where needed so that you can get kind of the variables that you're looking for that you can solve for. But yeah, so I got W2 or omega-2 is the square root of 3g over L, and A was 5/2 mg going up, and omega-2 is clockwise. And then B, we were just substituting values in, so 5.67 radians per second and 4.5 pounds up. And let's see, this one was kind of interesting to draw, but anyways, solving for I, and then you go to B2, and again do some substituting with L over 2, sine 30, all that. Then you get your T2, let's see here, yeah, and again T2 plus B2 equal T3 plus V3, and then you go ahead excuse me, and then you go ahead solve for your omega-2, which I got was 7.09 or 7.1 radians per second. Next one here was the tire that had the bar, or the I can't think of the name, tire iron that goes through, and it was off-centered. And so this one you have I equal mk squared, and we have those values there, and you get m equal 100 times 0.46, which of course is just 46 Newton meters. And then you have the axle, the moment about the axle here, which was, we had, 46 times 0.1, and then you divide that by 1.1875, so I got 3.87 radians per second. Next one, this one was the ball or solid, yeah, I think it was a ball, it's a solid sphere, which is where you get your I equal 2/5 mr squared. You get your y components, your x components, and the moment, and then you go ahead and solve for omega naught and t as well. And 6, didn't draw a picture for 6, and I don't think I drew one for 8 either, but I'm just bad at them, and I spend too long trying to make them perfect. So this one, you have I1, you have I2, you have H1, you have H2, which are equal to each other, so that one was kind of easy to solve. And then you solve for omega-2 as well. Next one was the bullet hitting the disc, I believe it was. And anyway, similar thing, y components, x components, moment. And then you can find your omega-1, which was, I believe, part A, and then B was your V2 and omega-2. So omega-2 was clockwise, omega-1 counterclockwise, V2 to the right. And the last one, yep, I didn't draw a picture for this one, but here we again have I. You have your different I's, of course, for your different shapes, different objects that are moving. But you get your V1, you have BC, which equal V of D, and anyways, do a bunch of substituting, and you get your H, what was that, H of C, yes, and then you have M of B, which equals M of E. You can solve for V1, B of C, and H2 with all of that. So that is about it. Thanks.